Hey everyone, if you can please join the Kahoot so we can get started right away, that'd be very much appreciated. I have the link in the chat, so you can get in right away. Uh, we can start class in about a minute, so I'll wait until 3 or 4 people have joined the Kahoot, and then we can begin our class. So I see that William currently has his camera on. I really appreciate that, William. If the rest of you can also have your cameras on, and if it's possible, you can also, if it's also possible for you to turn on your mics, that'd be great too. Okay. Now keep both your camera and your mics on. Okay, okay. We have 3 people. Okay, let's begin with a review of last class. I noticed last time we had quite some difficulty with, I believe it was prime factorization. So do I have any volunteers who want to give an explanation on what they think prime factorization is? Any volunteers? And thanks to Sean. I think Sean, I saw you had your camera on for a bit. Um, so Ryan, can you tell me what prime factorization is?
Prime factor, you mean?
Prime factorization. Yes.
You mean what I meant? Like prime factors, like, oh, wait, like, it's just like the composite number broken into a bunch of prime numbers.
Yes, so if you have a really big prime number, can someone please give me an example in the chat, please? Maybe just 2 or 3 digits.
You mean composite, not prime.
Yes, I'm asking for it can be prime, it can be composite. It just needs to be a number. The question I'm asking is, what do you think what does prime factorization mean? Okay, that number's a bit too big because it'll take quite a bit of time to factor that. I'm just gonna type in, let's say, okay, Sean, thank you, 123. So let's say 123, 123. If we were to, find its prime factorization, let's say you come across a test and it goes like, find the prime factorization of 123. Well, in this case, can someone tell me what number divides 123? Go ahead, Ryan. So I have 123 on the board. Let's draw factor tree.
3
Okay?
and 41.
So I'm asking what numbers divide 123. So what
Divide
can we break 123 down into?
3,
3.
41,
Okay, so we have 3 on one side. And then
41.
41. Okay, so we have 41 here. Can we break 3 down any further?
No.
Nope. 3 it's a prime number. We should all know that by now. It's only divisible by itself, which is 3 and 1. What about 41? Do you guys think 41 is a prime? Is it composite? What do you
Prime.
think? Is it prime? Why is it prime, Ryan?
It cannot be divided by 2 like any other prime number.
Correct. It cannot be divided by any other prime number other than itself, and any other number except itself and 1. So in this case, we have found the prime factorization of 123. So if, let's say, starting with our previous example, I asked, what is the prime factorization of 123? You would say 3 times 41. That's how you would write it. You take a really big number and you break it down into its components. I'm pretty sure we've done this example quite a bit, but last time, one of the Kahoot questions I asked went something like this. It was find the prime factorization of 36. So can someone tell me how we can find the prime factorization of 36, please? So, do I have any volunteers who can tell me what numbers go into 36? Uh, maybe whose iPad? May I know who iPad is? Okay, Sean. What numbers go into 36?
6.
6. Okay, so we can throw in a 6. What's the other number? So 36 is equal to 6 times what?
6.
Exactly. So we see that 36 is equal to 6 times 6. Is that it? Do we just leave it at that? Yes or no? Sean, I'm asking you again. So in other words, can we break 6 down into any other numbers?
Yeah.
Yeah, well, what two numbers can I break it down into?
2.
2. Okay, very good. So 6 is equal to 2 times what? 2 and
3.
2 and 3. Okay, so this 6 is, we can break down 6 into 2 times 3. Same thing for this one. This 6 can also be broken down into 2 times 3. And is that it? Do we just say 36 is equal to 2 times 3 times 2 times 3? Can we just leave it as that? Because it's kind of hard to write. So we can actually simplify this. And remember last class we learned exponents, right? So Ryan, how can we simplify this using exponents?
You mean 2 times 3 times 2 times 3?
Yes, how can we simplify this entire expression into something very simple? Oops. Exactly. We can write it as 2 squared times 3 squared. Thank you, Ryan. So in this case, oops, what did I just do there? Uh, in this case, we can write 2 times 3 times 2 times 3 as 2 squared times 3 squared. So this was one of the questions I think almost everybody they just stuck with 6 times 6 is equal to 6 squared, right? But when you're writing the prime factorization, you want to continue breaking it down. Once you see a 6, you need to know you can continue breaking it down into a 2 and a 3. And then once you see lots of 2s and lots of 3s, you say, aha, I can combine them. So 2 times 2 is the same as 2 squared, right? Or 2 to the power of 2. And 3 times 3 is just 3 squared. So it's 3 to the power of 3. 3 to the power of 2. Does everyone see where I'm kind of going with this? Why we're talking about like prime factorization? Yes? You guys can answer in the chat. Yes? Okay. Well, today, actually one last thing. I think I forgot to cover this last class, but another question I don't think we covered was, whoops, uh, another question I don't think we covered was how do we find the exponent? Let's say if I give you some big number, I'm gonna ask you guys in the chat to give me another big random number again. This time you can make it as big as you want. So throw me a random number, please. Okay, let's say we take this giant number Ryan had, this giant number, and then we raise it to the first power. Okay? What is the answer? What would the answer be? Ryan, can you tell me what the answer would be?
A big number, which
Yes.
I think you can make it like this.
Hmm? Okay,
If
so
you
if we
don't know
let
the big
x
numbers.
if we let x equal the first giant number that Ryan wrote, and then we raise it to the first power, um, then it's the same thing. It's the same thing as writing x. Okay, that didn't make much sense. Let's make the number smaller so we can actually give them names. Okay, I'm gonna go with the first one. Let's just say we have 4,362. Okay, well, I'm just gonna go with this number first. I'll use your number next, Ryan. So 4,362. Let's raise that to the first power. Um, can someone tell me what we can simplify this to? Sean, can you tell me what 4,362 can be simplified to, please? To the first power.
Uh,
It's actually the same thing as saying 4,362. So whenever you see something like anything raised to the first power, you just know it's the same thing, 4,362. So instead of a 1, let's say I put in some really complicated expression. Um, I know we're kind of into big complicated expressions today. Let's say I'm going to use Ryan's number, 6,963 raised to the 1 million divided by 1 millionth power. So what's this equal to? What would we
Six
simplify?
thousand.
The big number.
Yes, Sean?
Is this 6,963?
Okay, but why is it that? Why is it 6,963? Why isn't it something super, super big? Sean?
I think because the 1 million, it's a one.
Mm-hmm. So the 1
So
million, yes?
so 6,963. It's 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 so multiply 6,963.
Exactly. So the 1 millions, they cancel out, right? So 1 million divided by 1 million is simply equal to 1. And because you know that 6,963 raised to the first power is simply equal to 6,963. So it might look very, very, very nasty, right? But once you simplify it, all you get left is just the original 6,963. So we now know that anything raised to the first power is just itself. What if let's say I'm gonna zoom out and get rid of all this stuff. Um Oops. Yeah, this happens quite a bit. So let's say that instead of raising something to the first power, let's say I raise it to the 0th power. So I'll give let's go with another big number again. 500. Oh, this is big. 576. We raise that to the 0th power. Can someone give me a guess what they think 576 is equal to? William, can you tell me what 576 to the 0th power is equal to? William?
0. 576 to the
Uh,
power of 0.
what is it equal to? So how will we simplify it?
Simplify.
We can't? Okay,
I don't know.
you don't know? Okay. Well, for anything raised to the power of 0, the idea is actually really simple. You can actually throw any number down here, but whatever number raised to the 0th power is simply equal to 1. Okay, that's really how easy it is. So you can take some 1 million, I don't know, 1,076,892. You raise that to the 0th power, and that too is also going to be equal to 1. Okay? So you raise, okay, that didn't look very well, but if you get my point, um, can I have another random number in the chat, please? A small one, please. The long ones are a bit hard. They'll take some time to write out. Okay, so thank you, Jiren. Let's say we take 1,328. We raise that to the 0th power. So we have 1,328. We raise that to the 0th power. And this is the same as what? William, can you tell me what it's equal to?
130. I don't know.
Well, you
It's
take
6:15.
anything, you raise it to the
15.
0th power, it's equal to 1. And I'm pretty sure the reason this works, it's because 1,328, once you raise it to the 0th power, it's the same thing as dividing by itself, right? So you have this big number, you raise it, any number raised to the 0th power is equal to 1. Do you get that, William?
No.
Why not?
Mama, na.
Okay. Well, do the rest of you guys understand why a big number, any number actually, raised to the 0th power is equal to 1? You guys can just type yes in the chat. Because if so, then we can move on to order of operations, all right? Okay, so for order of operations, I'm not sure if you guys have learned this, but do we have anyone here who's familiar with BEDMAS? You guys can raise your hands or yes, Ryan? What does BEDMAS stand for, if I may ask?
Oh, wait, could you write the word down? What is it?
Okay, of course, you can write the word down. I'll let you write. You can write it on the whiteboard, please. That way it's a bit more
No, I
clear.
mean like which word?
BEDMAS, B-E, okay, I'll type it out.
Oh, I know. Like bracket, experiment,
Mm-hmm.
like division, and then multiplication,
Exactly.
fraction, and wait,
So the B, give me a second here.
bracket,
Yes, the B stands for brackets. Brackets. Oh,
experiment,
sorry, give me a second here. Brackets. The E stands for
experiment,
exponents. Yes. The D,
division,
division. The M,
multiplication,
multiplication. Oh, and A, I have to stretch this out a bit.
addition,
Addition.
and subtraction.
And S for subtraction. Thank you, Ryan. So what does this mean? I mean, it looks like a bunch of words, but what do they mean? Yes, Ryan?
How to like the correct way to solve them when there's a bunch of like a long expression, very
Exactly.
long with a bunch of set note. You just
Exactly.
you just
So,
solve the thing with bracket first and then
Mhm.
experiments by the way all the way down.
Exactly. So actually, two of these things, they're actually in parallel. So division and multiplication, they have the same rank technically. So if I were to see, I have to zoom out a little. Not sure. Okay. Oops. So okay. Um, so division and multiplication, they're actually on the same level. So is addition and subtraction, which means when we do anything, the first thing we want to check for are the brackets in the question. Okay, that might seem a bit vague, but follow along. Once you're done, you get rid of all the brackets, you do the math, and then the next thing you want to look for are exponents. Okay, you do the exponents, you get rid of the exponents. The next thing you look for would be the division and multiplication statements. These, you just need to look at them from left to right, okay? The same thing when you're reading. You read from left to right, so any math you do, you also do the math on the left, and then you do the math on the right. And finally, we do addition and subtraction. These are the 4 steps we partake to complete any mathematical expression, basically. So you guys all know what brackets are? It's not an actual mathematical operation, but you guys should all be pretty familiar. So some people they also nickname this uh they may not call it brackets, but you might hear people call these parentheses, right? And parentheses they are these things. They're like the arms, or you can see even put them in the chat. They're the curly braces or they're the square braces. So once you see those, you should be like ding ding ding, aha, I gotta do this first. So the parentheses or the square brackets, they tell you you better do this first because that's why we're setting this at high priority. Okay. Let's take a look at some of these examples here. So in the textbook, we have some terms. Okay. William, would you like to read this highlighted text, please?
Numerical expression like 5 times 8 plus 15 times 10 is a combination of number and operations.
Mm-hmm.
The order of operations tells you which operation to perform first, so that everyone finds the same value for an expression.
Okay, thank you, William. So the reason we're even learning this in the first place is because at one point in time, mathematicians, they would write something like this, okay? And let's say I wrote something like this, and then Ryan comes along and he's like, what is this equal to? And I tell him, well, I would just do 5 times 8 plus 15 times 10. And my answer would be something like 650. And then Ryan, he's like, no, I would do it 5 times 8 plus 15 times 10. And then he'd get a different answer. So me and Ryan, we'd be like, your answer's wrong. No, your answer's wrong. But actually, that's why we made we made BEDMAS in the first place. They're like a set of laws so that we don't get mad at each other just because we have different we do our math different ways. So we see here the key concept is worded very, very long, but it's the same thing as what I wrote down here. It's just BEDMAS. First we tackle the brackets, or parentheses, whatever you like to call them. Then it's the powers. The powers, the P, it's a consonant, so it's very hard to work into a BEDMAS, so we just use E. And then multiplication, division. Finally, we do addition and subtraction. That's the order we do operations in whenever we solve an equation. So Ryan, do you mind being the correct person in this argument here? Either Ryan. So let's say I wrote this expression down. 5 times 8 plus 15 times 10. All right. Say I wrote it down, and then I'd like we have two Ryans here, right? We have a Ryan who's currently are you a cat, Ryan? And then there's a Ryan who's raising his hand. So Ryan Lin, I'd like you to just work out this expression. Give me a second, please. So we have 5 times 8 plus 15 times 10. So completely ignoring BEDMAS, okay? Okay, I'll first let Ryan who's raising his hand, do it just linearly. So he would do 5 times 8, and then he'd add that to 15, and then he'd multiply it by 10. Okay? Can you tell me what the result of that would be, please?
You mean me?
Yes. So just work it out linearly.
The result of the expression?
So don't follow BEDMAS. Just do it 5 times 8, and then add that to 15, and then multiply it by 10. Okay? So what's 5 times 8?
40, and then
40.
15 times 10, 150.
Oh,
plus
no. You're supposed to add it linearly. I know this isn't how BEDMAS works, but because we have two Ryans here, which is confusing, I'm just gonna let you just pretend you add these first. If you just do it in a line. Okay, just pretend you have to do it in a line first.
Okay, and then 55 times 10.
Okay, you get 55 times 10. And what's
And then 550.
So your answer would be 550. Okay. Thank you, Ryan, who's raising his hand. Ryan, who has a character, Ryan Lin. Now try doing the BEDMAS way. So in this case, you would first do 5 times 8. Can you tell me what 5 times 8 is, Ryan? Ryan Lin? Ryan Lin? Right here. So what is 5 times 8?
Thinking. Okay, it's 40.
Okay, so 5 times 8 is 40. So this part here, this is Ryan who's currently raising his hand. Oops. Yeah, okay. So this part here is the expression. The answer here is the expression that Ryan, who's currently raising his hand, that's the answer he got. And now Ryan Lin, you said 5 times 8 is 40. right? What would you do next? So we have 40 plus 15 times 10. What do you do next? Brandon?
What?
So what do you do next in this expression? So do you do 40 plus 15 or do you 15 times 10? Can we please if you don't know, just say you don't know. It's kind of awkward to just be hanging on here.
I had no idea.
You have no idea? Okay. So yes, John, you can go to the washroom. Um if we're following BEDMAS, because Ryan, who's raising his hand,
Wait, I think it's like, wait, I think it's you add 40 plus 15 is my guess, though.
okay, you think that would be your guess. That's actually what Ryan, who's raising his hand, was doing. But we're gonna do it the other way. We're going to do 15 times 10 first. So what is 15 times 10? 40 plus, what's 15 times 10, Ryan Lynn?
15 times 10. Let's see.
Okay, thank you, William. It's 150. And can you finish it off, please, Ryan? So what's 40 plus 150?
190.
Thank you. So we have two Ryans and we have two answers. So which answer is correct? Can you guys tell me which answer is correct? We
Second.
have, yes, Ryan, who's raising his hand.
Second.
The second one. So why was your answer wrong? I mean, you just did it from left to right, so it seems like that's the answer. Why is your answer wrong now? Why? I mean, I told you to do it the wrong way, but why are you saying something else? Why is Ryan Lynn's answer correct?
Because the order of operation.
Exactly. So when we see something like this, it might be helpful for you to first group it according to the order of operations. So it might look like 5 times 8 plus 15 times 10, you just do it left to right. But in according to the order of operations, you should first be doing this part, which everyone did, right? 5 times 8 is just 40. Everyone did that. But after that, instead of adding 15, you need to do this part first. You need to multiply 15 by 10. So the actual question looks like this. It has these two brackets around it. That's how the brackets are invisible, but according to the order of operations, this is the way we should be doing them, right? So I know Ryan, who's raising his hand, if you just do it linearly, that's technically illegal, because we always prioritize multiplication over addition first, which is why the brackets, these invisible brackets, are around them. So in this case, we found that the answer is what Ryan Lynn should have been getting, which is, as we see, is 190. All right. Let's do another example. So over here, we have find the value of 4 plus 3 times 5. Okay. Do I have any volunteers who would like to read why this answer works? So what are the two ways we can do it? And what is the correct way? I'm going to do it the wrong way first. And then Garrus, can you tell me what is the correct way to do 4 plus 3 times 5? Okay. So let's say I have no idea what the order of operations is. And I go like, aha, 4 plus 3 times 5. I'm just gonna, oops. I'm just gonna do it from left to right. So here we have 4 plus 3 times 5. So doing it from left to right, remember I'm doing it the wrong way.
It's 6:30.
It's 6:30 times 5 because 4 plus 3 is 7, right? And then 5 times 7 is 35. Hooray! 35 is the answer. So is it the answer, guys?
No.
No. Well, Garrus, can you tell me what did I do wrong? Garrus? If you're not sure, you can ask for help.
I'm not sure.
Not sure. Okay. Ryan?
You did 1, then you just then I use the order of operation, like which is supposed to be 3 times 5 first, and then you
Ah,
add 4, and then you do 4 plus 15.
okay. So we see that this answer is wrong because you're not supposed to add 4 and 3. It's supposed to be, this is the correct answer. First, you're supposed to do 3 times 5, right? It's the multiplication statement. So you do 3 times 5, and then you add the 4. So, Garrus, what's 3 times 5?
15
15, and then
plus 4 is 19.
plus 4 is 19. So we have 4 plus 15, which is equal to 19. Okay, let's do a really quick example next. Single digit number, please, in the chat. Wait, single digit numbers, please. But I'll break that part into 2 portions. So let's say I have 5 minus 8 divided by 2. Okay, Jiren, I don't think I've caught on you yet. So can you tell me how we should properly be doing this question?
You mean me?
I'm asking for Jiren. Jirenzo. So how do we properly tackle this question, Jiren? You can unmute or type it in the chat. Okay, thank you. I think you're typing in 5 minus 4. So I see you've gotten the fact that we need to divide 8 by 2 first. And then what's 5 minus 4? 1. Okay, thank you. I'm pretty sure you're getting it, Jiren. Let's do another question. Okay, so Ryan, I think you gave some harder examples. Now let's throw something a bit harder in there. Let's try 47 minus 40, sorry, 45 squared plus 2 times 6. Okay. Do I have any volunteers who like to tackle this question, please? What do we need to do first?
Me.
Okay, Ryan, take it one step at a time.
So you do 47 minus 50. I mean
45.
45.
But why? Well, why do we have to do this first? Why can't I say, oh, 2 times 6 is 12? Why can't I do that first?
Actually, you kind of
Theoretically can. Yes, I know I can. But why is it, mathematically strict to do 47 minus 45 first?
because the bracket order of operation brackets first.
Exactly. So the brackets tell you, hey, you got to do 47 minus 45 first. So what's 47 minus 45?
2.
2. Okay, so we have 2. And then we have squared outside plus 2 times 6. I'll ask someone else. Any other volunteers other than Ryan? iPad? I'm not sure what your name actually is, so do you mind telling me your name and telling me what the next part of this problem is? Thank you, iPad.
Okay. Um,
So the current statement is 2 squared plus 2 times 6. And if you don't remember what we can do, what we're supposed to do next, remember BEDMAS. Okay. Do you remember BEDMAS, iPad? What's your real name, iPad?
Jagger.
Sager?
Jagger.
Chagger. Is that your name?
Yeah.
Okay, thank you, Chagger. So remember BEDMAS. BEDMAS, what does the B stand for?
14.
Oh, okay, the answer was quick, but I'm asking for BEDMAS. Do you know what the B stands for in BEDMAS? So BEDMAS is spelled BEDMAS, right?
Yeah.
And I should probably type this out instead. But what does the B stand for? So the B, remember they're all order of operations. You have BEDMAS. So the B stands for brackets. Brackets. They're like the curly braces thingies. Do you remember that?
Yeah.
Right? So B stands for brackets. And do you see any brackets in this problem? Oh man. What's going on here? So in this problem, Sager, do you see any brackets?
Yeah.
Yes. Can you circle them on the screen?
Yeah.
Do you know how to circle them on the screen, Sager?
I don't know.
There's like a little annotate button at the bottom left of our screen. I think there's like a tiny pencil on it. So if you click that, you should be able to draw on the screen. And then there's also a draw. There's also, yes. I think Ryan, he's already drawn it. So the brackets, they're currently holding the two. And okay, yeah, Ziran's also done it with an oval. Sean's also done it. So we see that there are indeed brackets in this question. Okay, can you guys keep it down? So we have the brackets, but then what's inside the brackets?
Two.
Yeah, inside the brackets just two, a lonely two. So you can't really do much with the two. So we're kind of done with the brackets. What's next? After B, there's an E. What does the E stand for? Shager?
Mm,
Do you know what the E stands for? Or can someone help him out?
yeah.
Okay, either Ryan or Sean. Okay, Sean. Oops.
Exponents.
Exponents, exactly. So are there exponents in this question? Yes or no?
Yeah.
Yes. So where's the exponent?
Bracket. No.
Exactly. It's outside the bracket, so
Yeah.
right over here. So we see that 2 squared. Jagger, what is 2 squared? Or what is 2 times 2? Shager,
Mm,
do you know what 2 times 2 is?
no.
Are you sure? You don't know what 2 times 2 is?
Yeah.
So 2 squared is the same thing as 2 times 2. Okay? And
Okay.
in this case, we can simplify it as writing a 4. So we've broken this down into 4 plus 2 times 6, right? And now let's continue looking downwards. We have BED. What does a D stand for? Ryan, can you tell me what the D stands for?
Division.
Division, correct. So, we can continue our list with division. Do you see any division in this problem?
No.
No, I don't see any division. Do you see any division? Well, I'm having a difficult time seeing division, so let's move on. What does the M stand for? Garrus, can you tell me what M stands for? Garrus?
Multiplication.
Multiplication, very well. And Henry, what does the A stand for?
Addition.
Addition, very well. So, oops. Do you guys see a multiplication statement in this expression? 4 plus 2 times 6?
Yes, sir.
Okay, thank you, Ryan. So what is 2 times 6? I'll ask Jiren. You can type type it out on the screen, or you can just put it in the chat. Either works. So we can also write this as 4 plus 12. Thank you. So 4 plus 12. And William, can you finish this off? What is 4 plus 12? Okay, Sean,
16.
16. Thank you. So the answer to this looks very complicated, really. You have 47 minus 45. Those are two pretty big numbers. You square it, and then you add 2 times 6. But if you follow the order of operations, you do the subtraction first, you square it, then the multiplication, and then you finish off with the addition. But we're not done yet. I mean, there was no subtraction here, that we didn't do yet. But okay, I just gave it away. But what does the S stand for? Jiren, can you tell me what the S stands for in BEDMAS? So the S stands for subtraction. Okay, thank you, Sean. I'm pretty sure you guys sort of get how we use BEDMAS. You're actually going to use BEDMAS for like the rest of your life. If you meet math, you are going to have to use BEDMAS. Like most math operations, they don't go away from BEDMAS. You have to use, you first have to tackle the brackets, then the exponents, then the division, multiplication, and finally the addition and the subtraction. So remember, the division and the multiplication, they're actually on par. You don't do one over the other. You just gotta look from left to right, right? So in most cases, you have to do it on the order of BEDMAS, but when you see either a division or a multiplication statement, they have equal ranking. So you just have to do the one that's on the left first, and then move on with the one that's on the right. So a really tricky question, I think, would be if I ask you something like this. What is okay, what is where's the pen? What is 18 divided by 9 divided by 2? So how would you guys tackle this question?
Left to right.
Who said that? Ryan? Was that you?
Me, yeah.
Yeah. Okay, so what would you first do in this question?
18 divided by 9 and then divided by 2.
Okay, so what's 18 divided by 9?
2 and then divided by 2, 1.
2 divided by 2, you get 1. Okay, so that's how you would normally do it. But sometimes something like this might come up. I think these numbers, they're going to start involving some decimals and stuff. So I'm going to change this 18 into 36. And change the 9 into a 6. So let's see how that works. Let me go out a bit, zoom in. So let's say the question instead was 36 divided by 6 divided by 2. Okay. Henry, can you tell me what you would do first in this question? Henry? What will we do first in this question? Okay, if Henry isn't here, Jiren, can you tell me what we would do first in this question? You can type it out or draw it out on the board if you want, or you can just type it in the chat. Okay, so thank you, Jiren. It is indeed 36 divided by 3. Why is it a 3? Where did the 3 come from?
It's 6:45.
6:45.
Yes, Ryan?
6 divided by 2 equals 3.
6 divided by 2 is equal to 3. And then this 36 divided by 3, can you guys give me the answer to that?
12.
12, exactly. So in this case, 36 divided by 3 is indeed equal to 12. Now, if I got rid of the brackets, do you guys think the answer is going to be the same, or is it going to be different? I'm going to put a poll.
Different.
You think it's different? Is it going to be is it going to be different, or will it be the same? So I'm not even gonna title the question. Let's put different. And then the next option is gonna be same. So let's save. What do you guys think? Let's say I got rid of the brackets. So I use my eraser here. I get rid of the brackets. Will this question be different, or will the answer be the same? Because remember, the original answer was 12. Ryan, I'd appreciate if you didn't scribble over the board, please, because I can remove your priorities here, your privileges. So same applies to you, Sean. Okay, I see that most people are choosing different. So in this case, what would be our first step? 36 divided by 6 divided by 2. What do we do first?
Divided by. The answer will be 3.
Thank you, Ryan. But do I have any other volunteers? Treg or iPad? I guess. What would be our first step? So when you see this expression, do you do 36 divided by 6 first, or do you 6 divided by 2 first?
This is 12.
So you try doing them one step at a time, right?
Yeah.
So do you do this part first? Do you do 36 divided by 6, or do you do 6 divided by 2?
6.
Right, so you would do 36 divided by 6, and
Yeah.
you get 6 divided by 2. And what's 6 divided by 2?
It's 3.
It's 3. So we see that simply putting brackets around an expression can change the answer pretty drastically, right? Before I put the brackets and then we got a 12. But this time I remove the brackets, and then we see that the answer became a 3. So that's why you got to follow the order of operations. If there were brackets and you were like, oh, let's just do 36 divided by 6 and then divide it by 2, you get completely different answers. 12 is not the same as 3. So just remember, when you do order of operations, make sure to follow BEDMAS. All right. Pretty sure most people got the poll correct. Let's see if there's an example, you guys. Okay, let's do this one. So you have two people here, and they seem to be conflicting over question. What do you guys think? Who do you guys think is correct? You have Haley. I'm gonna pretend to be Haley, and Ryan Lynn. You get to be Ryan. All right. So I'm Haley, and I say that 7 minus 3 plus 2 is the same as 7 minus 5 equals 2. And Ryan, who's also Ryan Lin, says 7 minus 3 plus 2 is equal to 4 plus 2, which is equal to 6. So I'm going to pull another poll, and let's see, um, let's see if you guys know how to use the order of operations. So who is correct? Who is correct? Is it me or is it Ryan? Or is it Haley or is it Ryan? Who's correct? Okay, I see people are trying to go in. Okay, I'm pretty sure the overwhelming results are that Ryan is correct. And maybe one person, I have a suspicion who I know who that person is. Someone's choosing Haley, but I'm pretty sure everyone knows it's Ryan. Why is Ryan correct? Ryan Lynn, can you tell me why you're correct and why Haley, or AKA me, why why is my answer wrong? Why is it not 2? Ryan Lynn?
I'm thinking.
Okay, I'll give you a chance to think. So remember, when we do these kind of expressions, we do them from left to right, right? Right, Ryan?
Yeah.
Is that true? Or do we do the right side first and then the left side? Are you here with us, Ryan? Okay, it seems Ryan Lin has gone on temporary vacation, so I'll ask Ryan, who's raising his hand. Why is Ryan correct?
Because there's no like for order of operation. There's no like multiplication or division or anything. There's only subtraction and addition, and they are on the same level. So you
Aha.
just compare left to right.
Exactly. So I think the reason Haley got it wrong is because she took BEDMAS a bit too seriously, right? She was like, oh, you have to do addition first and then subtraction. But no, addition and subtraction, they're on the same level, which means whichever one you see coming first, you see a 7 minus 3 come first, you just do the operation. So 7 minus 3 is 4, you add 2 to that, you get 6. But Haley, she took BEDMAS a bit too seriously. In this case, if we look at BEDMAS again, addition and subtraction, they're on the same level, which means if subtraction comes first and then addition, you have to do subtraction first. This is number 1, and then this is number 2. Okay, you have to do subtraction first and then addition. But if addition is on the left and then subtraction is on the right, then you need to do addition first and then you do subtraction. That's a difference here. This is you can't take BEDMAS too literally, right? You can't say, oh, division comes first and then multiplication. It just depends on which one's on the left and which one's on the right? So just do it the way you would read things, but otherwise just follow BEDMAS, okay? The reason brackets actually even exist is kind of to force priority into something. So let's say, hey, I really want to do my addition before I do my multiplication. Then you would put brackets, right? So usually I know I might want to do something like 2 plus 2 times 3. Okay? Normally you would do 2 times 3 and then you'd add 2. But if say, okay, this looks a bit weird, but let's say that instead I wanted to do 2, whoops. I wanted to do 2 plus 2 times 3, and I really wanted the addition to come first, then I can use brackets to force it to go first, okay? So in this case, can you guys tell me how you would solve this expression? William? Remember, BEDMAS. First is
Wow.
brackets. Okay, I see you've got
Wow.
your answer right away. What's the first step? So do you see any brackets in this expression? William? You see
Wow.
brackets? So the brackets are over here. They're around the 2 plus 2, and 2 plus 2 would be 4.
Four
So it'd just be 4 times 3.
equals
Then
12.
after 4 times 3 is 12. Very good. But let's say I got rid of the brackets. Let's put this example under here. If I have 2 plus 2 times 3,
Oh.
I don't have the brackets. What do I do next? Well, what's the first step I do, William? Remember BEDMAS. The multiplication comes before the addition. So we need to do the multiplication first.
8.
Exactly. The answer would be 8. You get 2 plus 6, and then 2 plus 6 is 8. So in the end, our answer would be 8. And we see once again that 12 is not the same as 8. And it all changed because I put in some brackets and then I got rid of the brackets. Okay? I think most of you guys have answered the poll, and it seems you guys are correct. Ryan was correct because if it's both addition and subtraction, you just do it from left to right. Okay. Okay, I think we have enough time to do a Kahoot. So if you guys haven't, if you guys
Chips.
are in, let's begin. I'll throw in the link. Throw the link in the chat. If you guys can please speed up, we can get this Kahoot started soon. Okay, thank you, Shiren. And whoever top G is. Fancy name. Sean, I'd appreciate it if you didn't post blockade links in the chat. Because this is supposed to be an official class here. So, if this is all the people we have, I believe we shall be getting started. If you guys need more time, just tell me in the chat or pop on your mic.
Start.
Okay, I will begin. Here we go. We talked about this. Nice. I see most of you have gotten it correct. And hopefully you guys don't go for the gag answers too often. Let's continue. Take your time. Okay, so the first one was a gag option, but the answer is when you take a really big number, it can be really big, but you break it down until all you have left are a bunch of primes, right? So primes would be 2, 3, 5, 7, 11, 13, 17, 19, all those numbers, they can't be divided by any other number than 1 in itself. So good job to everyone who got that right. Okay, this was one of those questions we had a lot of trouble with last week. And by simplified, I mean you want to compress it as much as possible. So you guys should know that red is not the answer. Right, it's way too big. I mean, would you like to write that entire expression out? It's okay, well, I guess some people still chose red, but and remember, I'm asking for the prime factorization here. So the people who did choose green, it is 2 to the power of 6. It's 2 multiplied by itself 6 times. So in this case, that's the 2 itself is a prime, and then because you want to simplify as much as possible, that's why you raise it to the exponent, right? It's not 64 because 64 is just 64. So just make sure you guys still understand what prime factorization is. Oh, got a big change. Doing good, Z-Man. Not equal to 0. Okay, good job. Remember, anything to the 0th power is 1. It's not 0, or else you'd get some weird stuff there. It's equal to 1.
It's 7 o'clock.
Okay, good job, Z-Man. Oh, sorry. This is supposed to be that big number to the power of 1, not to the 0. Yeah, so sorry about that. It's supposed to be to the power of 1. I apologize for the 3 people who chose 1 again, but it's this is a typo. Sorry, guys. Very good. See, we are mastering BEDMAS. Okay, so remember, BEDMAS, we need to tackle multiplication before addition. That's the entire point of BEDMAS. B-E-D-M. M stands for multiplication. We don't do addition. I mean, it does look like if you do it from left to right, you're gonna hit addition first, but you do the multiplication first before you do the addition, all right?
For the question, I got second step. I mean, in the question, not by BEDMAS.
Oh, well, the question, BEDMAS always applies. You're always supposed to use BEDMAS. It's not just, even if you see that question, you have to multiply first. You don't add. You didn't see any parentheses.
No,
So
I mean, like,
if there are no parentheses,
second-
you're not supposed to add. If you need help with that, Ryan, I can
Yeah,
provide after class.
I need help. I mean, like, by that, like, the second step of the question.
Yeah, well, the second step of the question would be because that question still had 40 plus like 10 times 15. The 10 times 15 was still there.
Yeah,
That's why you still had to multiply.
I mean, like, the first step, multiply. The
Mhm.
second step, you
Yeah,
add
but
it.
if you saw the expression, there was still a multiplication part. So you would
Yeah,
still have to do that multiplication. Hey, I actually did this problem in class. Take your time. Okay, very good. Remember, you're not supposed to add first. If you added first, then you're getting BEDMAS all wrong. Because remember, first you do the multiplication, right? 5 times 8 is 40, and then 15 times 10 is 150. So you would then add 40 and 150, smash it together to get 190. I think most people got that. The person who chose 550, just make sure you don't just move straight through, okay? It's BEDMAS. You have to do the division and multiplication first before you move on to addition. Okay, remember, we don't add first. We do BEDMAS. So it's multiplication, then division, then addition. The addition comes, it's always one of the last, unless there's like a subtraction or something. Okay, good job, guys. Okay, so the answer is not 0 because 8 divided by 2 is 4, and then 4 plus 0 is it's still 4. So the answer is it's just 4. It's not 0 multiplied by everything, right? I think someone might have like put imaginary brackets around everything, but there are no imaginary brackets around everything. Okay, good job. Okay, last question. Hey, you guys did pretty good. I'm not too sure how someone would have gotten 2 unless I'm actually having a pretty difficult time to see how someone would have gotten 2. But if you do the the brackets first. And then you do the division, multiplication, and then the addition. That's the 5 should be the natural answer. So let's just move on. All right, drum roll please. William, good job, William. Hopefully you learned something today. Top G, whoever that is, good job. And drum roll please. Yuan. All right. Good job to ED and me, who presumably, if that is me, I may have done an okay job. Well, thanks for everyone to have come here on Thanksgiving Day. Hope you guys all had a wonderful Thanksgiving, and I'll see you guys all next week. Great weekend, guys. Hope you guys
Bye.
see you later. Bye, Ryan and Ryan Lynn.